Okay, everybody, welcome back to ID24. Inclusive Design for 24 is brought to you in partnership with Barclays Access, the Paciello Group, Intopia, Microsoft Edge, and Open Access Technologies. Don't forget, if you like what you're seeing, please subscribe to the Inclusive Design 24 channel on YouTube by hitting that there subscribe button. And do not forget to tweet your questions to ID24Conf on Twitter. If you have any questions for our presenters, we will ask them after the presentation, and please use the ID24 hashtag so we can find them.
We would also like to say hello to all of our ID24U participants who are hosting meetups around the country/world. I know that University of Massachusetts in Amherst, Massachusetts has a group that's been going on all day. University of Michigan also has a group. The Nebraska Digital Accessibility Meetup has a bunch of folks as well. And I think coming online around nowish is the Northern Arizona University Disability Resources Group in Flagstaff, Arizona. And they will, it looks like, be staying with us right up through the end. So thank you all for participating.
We'd also like to welcome our co-host for the next couple hours, Terrence Eden. And I believe your cat also said hello to a few people in the background there too, Adrian. That was pretty awesome.
He does that.
So welcome, Terrence.
Well, thank you very much for having me. And it's been a fantastic set of presentations so far. Next up, we have Thomas Logan with what promises to be a brilliant talk. Let's make maps widely accessible. Something very dear to my heart. So over to you, Thomas.
Great. Well, thank you for having me. Really happy to be part of this event today. Amazing to see 24 talks in one day. And I am happy to talk about maps because really where I started in accessibility was maps. So I actually worked on my first accessibility project 16 years ago at the University of North Carolina. I was a senior in computer science, and there was basically an opportunity to work with a student in the classics department who was blind and needed access to an ancient world map. So that was my very first exposure to just the idea of what can accessibility, or how can technology affect accessibility and improve access to information. So specifically going back 16 years ago, thinking about, oh, how do we make a map accessible? You know, this very first project of mine working with the team, the idea was to take a map. On the screen, I actually have a ancient world map in the top left of the British Isles. And there was basically, as part of Jason Morris, who was a graduate student's research, he was analyzing some trade routes and different information about different points of where they existed in the ancient world. So on the screen, there's like probably, you know, over 100, couple hundred different data points on a map of the British Isles. And, you know, they're various distance apart from each other. They have color to communicate what elevation they're at in the world. So there's a lot of information, a lot of data packed tightly into a graphic. And so there's really, when we think about this visual information, we've got to think about ways that we can make that visual information be available through, you know, alternative modes and in ways that people can operate and be perceivable and all of those great WCAG things. So that project, you know, was a good success. It was just a single map there, right? And that was why I titled this talk, Let's Make Maps Widely Accessible, because I think what we see is that, you know, there are all types of different maps that have been available and continue to be made available. So this is just a quick overview of some geographic information system, GIS technologies, things like Google Maps, Apple Maps, Bing Maps, ESRI ArcGIS, Mapbox, Boundlist, OpenStreetMap, on and on. So basically there's all kinds of GIS technologies. And I think as a general rule, my experience has been that almost all of them are lacking some type of accessibility support, you know, really baked into the experience of building maps with their technologies. I'm very interested, you know, if anyone's watching this talk and is like, no, our technology really does have this stuff, I would love to learn about it. And that's one of the opportunities of getting to speak here today is that I would love to learn about what any of these companies are doing to really advance accessibility. But I wanted to preface this for most of my talk. I'm going to be focusing today on the Google Maps API, singling them out just from the perspective of I used it on a project. But I think in general, making maps widely accessible, I think the communication with all of these companies, if not more, there's really an opportunity to help improve the education of what they should be considering for accessibility and making this information more widely available. So I'm going to start now with a scenario for you all and just kind of walk you through. This is kind of 16 years later from working on a mapping project as my first exposure. This is me saying, okay, I want to take a problem set and think about how I would use a map visualization to make a cool solution. So this was in New York City where I live. There are lots of intersections and crosswalks. You know, there's all throughout the city, we've got, you know, crosswalks that people are crossing. We've got, you know, the typical signage of the red hand to tell you not to walk, and the walk sign tells you to walk. So that's a visual indication. But we do have in some locations in the city what's called an accessible pedestrian signal. So on the screen, there is mounted on a pole near the intersection what's called an APS for short, but it's a sonified indicator to tell you that intersection. It can communicate when the intersection has the walk sign illuminated or when it has the don't walk sign illuminated as one of its features. So in New York City, we've got tons of intersections, but we've only got about 200 intersections that actually have a accessible pedestrian signal deployed. And so I thought, you know, this is interesting, thinking about accessibility, thinking about who would actually want to benefit from this information. I would imagine a lot of people who are blind and low vision would like to have a good understanding of where these are available in the city, and possibly to also advocate for where they should be put in the future. So the desire here was to look at how I could visualize that information to make it more understandable, to find where are these accessible crosswalks in New York City. And I've got a few different images of 4 different images of some places where they exist. One in Times Square, one kind of out in more of a nature area. So they're kind of all spread out through the city. When you go to the New York City Department of Transportation site to find out where they're located, there's a report, but it's only available as a Excel file. So in one respect, that's very accessible. We've got a data table like presentation of the information, but we really can't get, you know, any understanding of the spatial relationship, like where exactly are these put? Are there clusters of these pedestrian signals that have been put in certain locations? It is just a flat set of information. So this was sort of my starting point to say, okay, here's the data set, and I want to now visualize that data set and make it more available for people to interrogate and ask questions about. So I was like, well, I will use the Google Maps JavaScript API. Let me go to Google Maps platform, go to their SDK, look up how to do that. So I want to do that. I go, and one of the starting points, probably where tons of people around the world start with making a map visualization, adding a Google map with a marker to your website. So this is in the SDK, your developer's guide. They have a sample of Australia with just a single data point. Nothing actually in a tooltip or anything at this point, but they give you the code of how to build that, and you could basically cut and paste that code and get started really quickly on building your own, which is really pretty much how I started working on my first instance of visualizing this information. I basically started from the SDK, took the sample, and then started customizing it from there. So what I ended up with at first was, this is sort of my first implementation. This was scraping that information from the Excel file and then creating a marker for every location. throughout the city. So when I got this loaded up, for someone that can visually see the screen, we can now see about 200 different data points spread across the 5 boroughs of New York City. And for someone that can operate a mouse, I can interrogate this information. I can move my hand pointer around. I can double click, zoom in. I can look for visually where are a bunch of these clustered. There's a whole bunch of points. So one thing very interesting, the one area in downtown Brooklyn, you can zoom in visually and see, oh, there's actually like a certain part of New York City where there's quite a lot of accessible pedestrian signals, almost at every intersection as you cross various streets. That's one of the ways that this visualization gives you, more access to understanding the problem than if you were working with the spreadsheet. But all of this is being done with the mouse. I'm double clicking, I'm clicking and dragging. If I wanted to get information on a specific data point, I'm clicking on that data point and seeing a tooltip that appears. So this particular data point is pointing out that I'm at Adams Street, Forum Place, and Livingston Street. And this isn't explained that well, but this was deployed, this particular pedestrian signal was deployed May 9th in 2012. And so again, I can get this information if I'm able to click on the map and interrogate the data points. But as I was testing it, everything I do, of course, I need it to be accessible and want it to be accessible. The first thing is just trying to use the keyboard, or, our standard test of like, let me tab into the visualization and see if I can get to the data points. And by default, basically the only things that receive keyboard focus when we create this visualization is the maximize window button, and then the zoom in and zoom out buttons. Those I can control from the keyboard, and I can press escape to maybe like collapse and expand the view. I can hand the container with the arrow keys, but I can't actually get down to these individual data points. And so I thought, that's actually, I'm just following the SDK. I built this, wasn't something that I was going to be doing as like a full-time project, just was interested in exposing this information and making it more available to folks. And it brought me down this path again of, well, what do we need to do to make maps more widely accessible? I thought maybe I did something wrong. Maybe I, didn't follow directions right. So I go to the platform, search for the word accessibility, and there's no suggestions for your query. So, when I'm looking or trying to figure out if there has been any work, this is usually one of the first search terms I put into a site. And ideally, I'm hoping to find guidance. At a minimum, it's like maybe it wouldn't work by default, but there's some helpful information that says, oh, well, you need to add these attributes, or here's the right way to use the API to get that type of support. But when I went looking for that, couldn't find any information. So then I'm like, okay, well, because I work in this compliance field, let me go look and see if they have like a VPAT or a documentation of what their accessibility is. And interesting, thinking about how our technology world works, the VPAT's actually from September 22nd of 2013, so ages ago, but accurately represented inside of the compliance document is that, basically there's not keyboard access into those points, and that, the developer is going to need to do additional work to make that available. So, accurately represented, but I think at this point, this would be a great opportunity for Google and or other mapping visualization companies to really take a lead and make this easier for developers. At first, at a minimum, just documenting, here's the right way to use the API, or here's an example of how you can use the API to get this behavior. If you go to Maps, Google Maps site itself, it's got great accessibility. The team that works specifically on that implementation of exposing the maps, they've added a lot of accessibility functionality, but none of that's really documented or made available either for people to learn from or to learn the best practices from. I just wanted also, as again mentioned, ArcGIS, which is another popular mapping one. This is an example of a very similar SDK sample from theirs, where you're putting some data points and clusters on a map. Same issue with you can't get keyboard access down into the individual markers on the map, and you don't have sort of like a data alternative by default in that sample that lets you get what's being exposed through the tooltips at that point. And OpenStreetMap, which is another kind of current mapping technology in the like open source world and getting a lot of interest lately. The OpenStreetMap for controlling a marker and placing a marker, also very similar. You can get keyboard focus to the controls to zoom and control the viewport, but you can't get, at least in the quick sample that I looked at, you could not get keyboard support down into the individual marker or get to the associated information with it. So I put, my heart's breaking here, some common issues for map accessibility. Individual data points require mouse or touch input. There's no text alternative to complex visual representation of information. Zooming, rotating, and manipulating the map often lacks a keyboard equivalent. And then color contrast, which I'm not really touching on here today, but I think that comes up quite frequently when we're talking about any type of visualization, but the colors and the way that we're placing markers or placing different sets of information on the GIS visualization that can come up, color contrast and color as the sole means of communicating information. So what I wanted to get to here is to just show some of the work that we did on a specific Google Map implementation to make it accessible, and giving a shout out to Coast Plakosha on my team here at Equal Entry. We worked together on kind of trying to get this implementation to be a best practice. And we have a link to the GitHub repository for the code and hope to continue working on it. So the first piece, just to explain what's been done so far, was the kind of valid assumption that, hey, if you put every single, if we were going to make every single data point keyboard accessible on this map, it would be 200 different tab stops. If we're going to go with a simple route of let's figure out how to get keyboard focus to those. So we started with trying to use Google's cluster, or we used Google's cluster functionality to be able to group some of the different points so that on the screen, one of the first ways of navigating into the map is that you just get keyboard tab stops for, I think it's about 10 different clusters. So, I think it would be a best practice or open for discussion, but I seem to see that a lot of mapping sites that have either like a list equivalent or a data equivalent, they kind of try to get it around about 10 tab stops or 10 points that you could navigate through with the keyboard. So that's what we aimed for just by default when you first come to the visualization, is if you wanted to just dive right into the map itself, you can tap through those points and you can get a accessible reading of the cluster information. Also added inside of the idea that basically that's searching around and looking for specific points. I think this would benefit everyone, but probably most people that are thinking, where are accessible pedestrian signals in New York City? They're thinking from the context of themselves, like, where do I live in New York City and is there one near me? So kind of starting from that point that you should probably, in most cases, really thinking about how we would make this a better experience. We would want a way to actually navigate down into the section of this visualization that's actually relevant to us. So I had a couple sample ideas just to start from, a couple scenarios. We would start with, let's say I lived at 645 Manhattan Avenue. I can type this into the search address and, got keyboard access. I can hit the down arrow, select from different results, but I'm going to search on that address. And now the map is updating, kind of zooming out. Well, by default here, we're still just trying to fit up to 10 points. that can fit on the map. And so what happens is that right now, visually, Greenpoint is sort of in the center of the map. The address that I typed in got centered, and visually we can see that there's really not any data points very close to that, that address that I typed in. They're mostly in Manhattan. So that's something that we can see visually, but to give a different equivalent, we made a data table view of the same information, but filtered to what's actually being shown in the visualization. So when we filter this list, we get the name. The name of the table is nearest signal locations. We get the name of the intersection, the distance from our search term in miles, and then the date that the signal was created. Again, it's kind of a mashup here of thinking about these uses. Maybe people don't really care when it's created, they just care, is there one or not? So the closest one to this street address, these are the results are ranked just by distance right now, is Grand Street and Ridge Street. That would be the nearest location, and it's about 0.93 miles from where I searched from. So at least from the standpoint of trying to understand this problem set, I have been able to interrogate this visual information, put it into a data table representation, but I've been able to dynamically update the data table based off of the user's intent. Like, I just want to figure out what's the closest one to myself. So also added, this is kind of old school world, but I added a visualization to show access keys to more easily move around the focus in this app. So when you hold the Alt key, the letter visually that would move focus to that control has an underline underneath it, which is how Windows menu items used to always tell you how you could move keyboard focus. So if I want to move back to the search address, move the access key for S, and I'll type in a different search. So now let's say I live in Jackson Heights, Queens, and type 3327 80th Street. So I'm still filtering on the view data. And so now I'm getting that, and in Jackson Heights, actually, the intersection that's closest is actually Corona Avenue and 94th Street, and that's 1.22 miles away. So it's, again, still fairly far from where this search address is. The last one is just to type in 99 Shimmerhorn. And this was the one that visually we could see there was a lot of different data points clustered. This one, we're actually getting results that are within 0.04 miles. And so we've actually, if I switch back to the visualization, got a bunch of different data points there, but we've got tons of data points that are still within, under a half mile. So in this particular address, someone living near 99 Shimmerhorn has a lot of accessible pedestrian signals available to them and in close proximity. So I think that's, again, showing that having this information that you could filter it in a different way, you can still ask the same questions and gain access to the underlying information. You're just not doing it visually by clicking and positioning, a touch pointer around on the map. So I think one of the viewpoints is that I think from an API perspective, a lot of visualizations, or a lot of the ways that people use at least the marker scenarios on their sites, is mostly just needing to have different points that have tooltip information associated with them. And sometimes it could just be a single piece of information. Sometimes it would be structured data. There might be 10 different attributes related to that particular data point. And that's something that via an API could be put in as like a best practice of, well, if you need this functionality or you want to have a data table alternative for your visualization, here's how you use the API to get that. So that's kind of the point that we have this code. We did some documentation of adding some ARIA roles, some tab indexes, some on focus and on blur support to make sure that if when you're tabbing, the tooltip actually does display on focus and on blur. And then the last part, which we added in, and I'm not going to cover too much here, but I think is super interesting, is let's thinking even farther. How do we make maps accessible? Well, now you can get a street view visualization via the Google Maps API. So you actually get a picture of what the location in the world looks like. And so this is 360 equirectangular image for that location. And again, this would show that the data set that was published from the Department of Transportation just had intersection names, but we could get more specific with like latitude and longitude. And visually in this rectangular image, I can click and zoom, and in most of them, I can actually figure out, oh, there's the accessible pedestrian signal that really is deployed at that intersection. So I'm able to do all of that again, because I'm able to see this visual screen. But I think this is still another opportunity for advancement with the advances we have in artificial intelligence and object recognition. Having some of that information come through automatically in these street views would be another cool feature to say, like, well, if I read the the visualized information for that data point, I should have an alt text that maybe tells you, like you get with Facebook when you upload an image and it automatically tries to add text alternatives. It'd be really great if it was actually tagged and had, hey, this is where the APS is in this image, or this is, a crosswalk at this site. I didn't have time to make the recording today, but I'll try to send this out as a follow-up tweet. There's a new feature in Windows 10 with Narrator where you can run a keystroke sequence to send an image up to the cognitive AI services and get descriptions back of the image when you focus them. And I was actually, there's obviously still a way to go, but I was pretty impressed with how well that worked actually in at least getting information from some of the street view images of, like, there's a police car here, there's a motorcycle here, there's a crosswalk here. Sometimes the text that's displayed visually in the photo street view was also coming back through those cognitive services. So I kind of just threw this in here too to say, I think the first place to get to is, getting our data visualizations, just sort of our standard data visualizations accessible. But I think as we see, there's a mashup of augmented reality and other information coming through in these mapping technologies. The text alternatives for those images is also an important area to consider and request innovation. One other point, and again, didn't have too much time today, so I just wanted to make another point from another demo that I have linked in the references for this talk. But thinking about a user with some type of motor impairment, maybe a user using a switch access device to control or navigate a visualization. This is a simple example of showing how we could put actual visually displayed controls to pan the map and zoom the map up at the very top or at the very beginning of the visualization, and have that be able to be controlled pretty quickly and efficiently with a switch. So on the screen, I have an iOS switch device. I have the switch access on my iPhone running, and I'm able to, with a single tap, control and move around the viewport of this map of the United States. And again, that shows that one thing also to consider for maps is that having those button equivalents or having some type of object that can get focused to control and manipulate the viewport would be something also to think about for how could we have that more built in as a default experience for people that need a different type of input mechanism to control the visualization. All right, so and then kind of want to wrap up here with just my whole point of, like, let's get map accessibility widely implemented. Lots of maps use the Google Maps API. I just pulled a few different examples. This is a commercial real estate site, HFF. got a bunch of data points for where their office locations are. So if someone was coming to the map and wanted to figure out the contact information of, okay, how do I talk to the office in North Carolina? We're right back to this issue of needing to click on this data point. Maybe that's available somewhere else, but the default is getting into the, into that. This is Canonical, an Ubuntu services site, so showing some diversity here. They're also showing their different office locations around the world. And again, it's one of those things where, just like me using sort of the default, just putting markers on the map, having the same access issues that I did. Here is an example from New York State. I want to find the campgrounds in New York State, and I explore where those are located. And this is just different visual rendering of putting markers on a map, but has all the same accessibility issues. And then Google, in this case, the people that are responsible for this SDK, their Google I/O event, the developer conference. This is an example from 2018's conference, the map, the event map to actually figure out where the different events were happening. Also using the JavaScript API, and has the same issues exposed on it. So, when we think about what needs to happen, I call back to one of the W3C specifications, the authoring tool accessibility guidelines, ATAG 2.0. We want to help authors create more accessible web content, specifically enable, support, and promote the production of content that conforms to the Web Content Accessibility Guidelines. So, it's basically my belief that to get really widespread adoption or implementation of accessible map visualizations, it's going to need to come from the people that build these platforms, that build these systems. Expecting every individual site author to do potentially what Kos and I did for our map visualizations, not very realistic, and also is just something that, maybe in certain instances would become available, but these are one-off maps. This is just one of potentially thousands of visualizations. So I think when we think about the authoring tool accessibility guidelines, APIs are definitely a place that we need to be thinking of this as well. Like, how can we enable, support, and promote the production of content, that easily conforms to these guidelines. So I had just a call to action here. This is a issue that we created in the Google issue tracker. So this is just one, and like I said, I think this is worthwhile endeavor for any mapping visualization tool that you might be using in your organization or in your workflow. But we've created, I'll be sending out a link in my tweet. We've got 91 people currently that have starred this issue. You can go into the issue, and there, if you log into the issue tracker, there's a star icon to favorite the item. And I would recommend, as a comment, probably the most impactful would be if you are actually using the Google Maps API in your organization or in your workflow, to provide that information and let them know, that, hey, I'm having the same issue. I actually learned about the Google I/O event issue from reading some of the comments inside of this bug. And what's at least very encouraging from the Google side, this used to be set at priority 4, severity 4, which I think is about as low as you can go from a prioritization standpoint. Very recently, at the very end of this thread, I think September 24th, we had, or very close to them, we had a change in the priority be moved up to a priority 1. So I think that's encouraging, and I just wanted to encourage folks on this presentation, watching this presentation, that I think putting your contributing to these feature trackers, these issue trackers, making sure that the people that work on this functionality at these different companies are aware of your own concerns or your own issues with accessibility. A lot of times that can help support the organization doing that work, and it can also help provide scenarios. Like I would think if Google is able to work on this functionality, having a broad set of, like, here's different ways people are using for example, the marker functionality. Let's think robustly about how we can make this easier for everyone and make it that by default, lots of these visualizations are accessible. Just wanted to kind of wrap here that, I mentioned I'm really focused on the Google scenarios in this talk, but I'm very interested in, a lot of other companies. I've got a little extra time here, so I'm going to actually show you all one cool function that one of the developers at ESRI ArcGIS put a comment on my blog when I wrote about this topic. So basically the ESRI team or the ArcGIS team is looking at, I guess, hopefully building in this functionality as well. And so there's a GitHub for, and I actually will have this in the references for this talk. This is A11Y map, Kelly Hutchins, and then we have from the map there is actually a live version of the implementation. Basically, what's been implemented on this map is using the arrow keys to move around the map, using plus and minus to zoom. And then there's this selection box that actually gives a output onto the screen. So as you're moving sort of a viewport finder around on the screen, there's a sort of status window at the bottom of the screen that's updating text dynamically. So it's a way that we could get information about basically where the mouse cursor or the mouse pointer is at. Let me look at his instructions here again. Press the associated number key and press the I button to learn more about the direction the box is moving and the current location. So I think, that's another thing for us to think about from getting maps to be widely accessible is probably the keyboard shortcuts. Understanding what are conventions and, similar to how other design patterns have been built for sliders and tree views, getting some of those patterns to be established, for map visualizations would be helpful. And then with WCAG 2.1, also allowing those to be remapped or be configured to a user's specific preferences. But again, I just say I'm encouraged that Esri is working on this. Just point that out too as a resource for people on the call that might be interested in learning more. Tal Zhang is who's currently working on this functionality or pointed this out, and Kelly Hutchins is the GitHub maintainer for that project. All of the references for this talk, I will be tweeting a link out to this, but I put a post of this presentation. All of the different presentation content that I covered in this presentation is available at equalentry.com/inclusive-design-let's-make-maps-widely-accessible. So you can get to all of the examples that I showed today, and you can also get to the link to request the accessibility support in Google Maps. Thank you. Do you have any questions?
Oh, that was great, Thomas. Thank you very much. I believe we did have some questions from the Twitterverse.
That's right. Yeah. So I've been taking a look at what's on the hashtag ID24 on Twitter. So yeah, we've a few questions here. I wanted to start with this one. So you mentioned about the accessibility issues with Google Maps. How does that compare with some of the OpenStreetMap products, for example, leaflets or things like that? Are they more accessible, less accessible?
Yeah, so that was where I was basically coming from. I don't have a lot of information. I hope to kind of gain that information from, putting this talk out there. I did go to OpenStreetMap's website. I think I put a link to it. They do have, at least when you run the accessibility query on OpenStreetMap, you do get to this page about disabilities. Oh, sorry, I'm not sharing my screen. Or am I? Yeah.
you're not at the moment, but that's good to know. So things like OpenStreetMap are also looking at accessibility features as well.
Yeah, and I think that's definitely a place too to this would be the place to engage with them. There's a mailing list that I found for to talk about these issues. So if you're interested, that would be the place to probably ask specifically about leaflets or that area.
We had a question in from Joshua Pearson, who was, and this is a question that I found quite interesting, which was you're talking about enabling keyboard functionality on these maps, but how can you do that so it doesn't affect native screen reader commands?
Yeah, so that's a good question too that I didn't actually run through on this site, the demo of running the screen reader with it. But I think that was one of the challenges too, was thinking about how do you keep it so that if you're running this on a mobile device, using VoiceOver on iOS or TalkBack on Android, NVDA on Windows, or VoiceOver on the Mac OS, you want to try to keep the keyboard functionality in some way, not to interfere with all of those. I think one of the points is that the simple sort of logical navigation, go forward, go previous, let me read the next element, let me read the previous element. That was sort of what we tried to optimize at this point. Was we didn't have, for example, keyboard shortcuts to get, to the first or the closest data point and the second data point, or to move, to the data point to the right of the data point that I'm currently focused on. I think all of those things are, though, to the point it would need some type of standards work, and ideally it would be that as these patterns become consistent, then we'd be able to make sure that they don't interfere with the screen reader commands. But yeah, I would say that trying to do things that are too advanced or using keyboard shortcuts, that's definitely why we have WCAG 2.1 now saying to allow people to remap them or configure them. So that's still also, I think, an area for innovation and making that easier.
Yeah, it does sound like that. And there's a similar question from, let me just get the name. It's UMass Amherst, talking about speech input and speech activation. So we know lots of people use voice to text to control their computer, control their phone. Have you seen any work on using voice to control maps?
Yeah, so I actually think that is a great area to go. I mean, I've seen it in the context of basically, I think voice access on Android is working really great. That's that particular product. I think it's in the latest release of the Android operating system. It feels even faster. So I think that one specifically, with my example implementation, the labels that were actually marked on here are what would currently be picked up, but that tool also can number them, and place numbers next to all of the points that have keyboard stops on them or that are accessible elements. So I would say that's the one that I'm kind of aware of right now that's for speech control, that's sort of a built out product that's freely available, works well. I haven't used any of the speech input APIs myself to try out or seen any.
Okay, and one more, although to anyone who's watching, please leave your comments on hashtag ID24. Right near the start of your talk, you showed that you had a spreadsheet showing where accessible intersections were, things like that. Now, I'm assuming that was released by the local municipality or local government. Is there a way that people can get involved with their local authorities to say, hey, it would be great if you could release pedestrian signal stuff in an open format or as open data? Are there any groups which are sort of agitating for that, or any ways that people can get involved?
Yeah, I think that it's actually interesting that Barcelona and New York, actually what got me into this ideation phase of working with this area was there was a call for innovation, at least in New York City and Barcelona, to think about creative ways of addressing the sort of lack of accessible pedestrian signals, or maybe using technology in different ways. I know I can just speak for those two municipalities that they have that interest in them, but I would imagine it would be something worth contacting your local Department of Transportation or the equivalent organization and understanding that. I know at least here in New York City, there is a lot of work, as you mentioned, open data. A lot of the information is getting put into that. And so that is one of the places that that would be one of my follow-up requests to the city is like, it would be great if I could have just gotten those data points from like a data set that was, structured and already sort of set up to make it really easy to facilitate this information sharing. The Excel file was, a lot of work.
And I'm certainly going to go around asking my local council in the UK whether they make this data available. We've got time for, I think, one more. There's one just come in from Jonathan Paul Katz, and this is something which, again, it's really dear to my heart, about the accessibility of multilingual maps. So if you're in Barcelona, you're going to see maps outlined in Spanish, China, there'll be Mandarin. So how do you program scripts for accessible maps to deal with that? So should it read you the name of the place translated into your language, or keep it original, or if you don't speak Chinese, should you see something else? I think that's a fascinating question. So I wondered if you had any thoughts on that.
Yeah, well, I mean, I can just speak anecdotally that the time that I traveled, the first time I traveled to Russia, and everything was in Cyrillic, and I didn't have a tool like Google Maps. I was completely lost. Didn't really have any understanding of how to get around. So I would say that it's based under the understanding of, if someone does understand the language, if I had spoken Russian fluently, then if the map is rendered and available just in that language, making sure that it is marked up with the right attributes so that it's pronounced correctly would be the typical best practice. But if you are thinking about this already in an environment like we are in New York City, where you need to have support for multiple languages, then I guess having that ability with the data set to toggle the way that the language text or the strings that are being associated with each data point, that those can be updated or modified based off of the user's language request, or maybe navigating to the page for that language. But I would say that normally it would be probably setting it just for the overall map in general, versus maybe like one or two different data points that might have a different pronunciation. But like you said, I think it's a fascinating question. I'd love to look at examples or understand it more.
Well, that's great. Again, thank you very much, Thomas. Fantastic presentation. I think it's one of the higher viewer counts we've seen all day, for sure. Just a reminder to everybody watching at home, if you did like this presentation, please hit that like button on YouTube. And don't forget, you can subscribe to our channel for future notifications. Just a reminder that Inclusive Design 24 is brought to you in partnership with Barclays Access, the Paciello Group, Intopia, Microsoft Edge, and Open Access Technologies, with thanks to our sponsors, DQ Systems. Inclusive Design 24 will be back at the top of the hour. Up next, we have The Power of Alt and Lang Attributes with Ronaldo Ferez. Thanks again, Thomas, and we'll see you all back at the top of the hour.
Thank you.